For over 130 million years, our planet was dominated by diverse and extraordinary reptiles known as dinosaurs. The first non-avian dinosaurs appeared during the late Triassic period, between 245 and 235 million years ago. Diverging from early reptiles, dinosaurs diversified during the Jurassic and Cretaceous periods, bringing about hundreds of unique species, including some of the most enormous monsters to ever walk the Earth. But other strange and fascinating animals lived on our planet long before the dawn of the dinosaurs. Roughly 100 million years earlier, the Earth was flooded by warm, shallow waters, producing swamps, wetlands, and vast tropical forests. These rich, highly oxygenized ecosystems were home to the gigantic relatives of modern arthropods. Bird-sized dragonflies swooped down from the skies, capturing small insects in their spiny legs. Prehistoric millipedes, as long as small cars, crawled through swampy underbrush, possibly snacking on club moss and sporophylls. Some of the largest arthropods were eurypterids, or sea scorpions. The earliest eurypterids probably lived in the ocean, using their wide appendages to gracefully navigate the salty shallows. Over time, eurypterids adapted to fresh and brackish waters in marshes and river deltas. There, giant species swelled to over 2 meters long. The largest was Jackalopterus, an agile and powerful hunter that crushed its prey in its oversized claws. Living alongside giant arthropods, amphibians were some of the first vertebrates with legs adapted to walking on land. Back then, one of the most populous amphibians was Diplocaulus, a salamander-like animal with a distinct boomerang-shaped skull. Diplocaulus probably lived in swampy ecosystems around bodies of water. Preying upon insects, gastropods, and small fish, Diplocaulus may have used its strange skull to cut through water currents and surprise its prey from below. Amphibians, like Diplocaulus, laid shell-less eggs, so they were mostly bound to bodies of water. However, new vertebrates called amniotes were surviving and reproducing further from the water's edge. The evolution of hard-shelled amniotic eggs allowed amniotes to explore and populate a diverse world of terrestrial flora. In these thriving ecosystems, lizard-like animals filled new ecological niches, setting the stage for critical evolutions in terrestrial life. Around the same time, our planet underwent significant and widespread geological changes. Most of Earth's major landmasses were converging into a C-shaped supercontinent called Pangaea. Over hundreds of millions of years, continental movements altered coastlines, closed seaways, and created giant mountain ranges like the Appalachians. Terrestrial ecosystems gradually became more isolated from seacoasts. The world's rainforests and wetlands shrank, and Pangaea's climate grew hotter and more arid, enabling unprecedented diversification of terrestrial life. Seed plants with fronds and woody trunks grew in tropical and subtropical habitats, high in oxygen and teeming with terrestrial life. The early relatives of grasshoppers, crickets, and locusts bounded between branches and hanging vines. Permian beetles chewed on the woody tissue of dying trees. Early reptiles called sauropsids scuttled across the forest floor, taking shelter in fallen branches and mossy underbrush. Pangaea was also home to giant, sail-backed synapsids, like Dimetrodon, an apex predator stretching up to 4.5 meters from head to tail. Superficially reptilian, Dimetrodon had sprawling legs and differentiated teeth, but its most distinctive feature was a tall dorsal sail, which it may have used to regulate its body temperature. These innovations enabled Dimetrodon to thrive in subtropical deserts and swamps, where it likely fed on early reptiles and amphibians like Diplocaulus. Because of its size and appearance, Dimetrodon is often mistaken for a dinosaur, but these huge sail-backed carnivores were more closely related to mammals. Not until the Middle Permian did any creatures start to resemble the mammals we know today. One of the earliest groups, called therapsids, lived in the shadow of larger carnivores like Dimetrodon. At first small and slender, therapsids grew larger and more dominant over time. Eventually, bulky herbivores with tusks and horny beaks filled the world's forests, chomping on low-hanging branches and ferns. Giant carnivores ambushed their prey with crushing jaws and saber-like teeth. Among the largest Permian therapsids was a massive, awkward animal called mozchops. Found in the semi-arid regions of modern-day South Africa, mozchops was a stalky plant-eater measuring over 2 meters long and weighing upward of 320 kilograms. To carry its hulking body, mozchops had notably large shoulders and wide-set elbows, plus an incredibly thick skull. Paleontologists believe males competed for mates by clashing their thick heads together, similar to modern-day rams. While therapsids dominated the Permian period, Pangaea's forests and deserts were also populated by new species of reptiles. The earliest genera had long necks and sprawling bodies, but these animals quietly diversified throughout the late Permian. Early reptiles may have struggled to compete with therapsids like Dicynodonts and Gorgonopsians, leading some species to become highly specialized. Vigeltosaurids evolved wing-like membranes that allowed them to fly between trees and potentially snatch insects out of the air. Semi-aquatic reptiles like Claudiosaurus found their ecological niches underwater. Evolving webbed feet and an undulating body, these reptiles lived among spiny fishes, conodonts, and even the relatives of true sharks. Before the end Permian boundary, another significant group of vertebrates emerged in the arid regions of Pangaea. Known as cynodonts, these advanced creatures had differentiated teeth, secondary palates, and primitive endothermic metabolisms, which made them highly adaptable to different environments. The earliest known cynodont was Procynasuchus, a semi-aquatic genus found in modern-day Germany and parts of Africa. Paleontologists hypothesize that Procynasuchus lived a lot like today's otters. Using its long tail like a motor, it was likely a strong, agile swimmer, able to chase small fish through tangles of aquatic plants. After catching its dinner, Procynasuchus returned to dry land, where it may have rested and tended to its young. But the world in which Procynasuchus lived was steadily approaching one of the greatest disasters in Earth's history. About 252 million years ago, near the end Permian boundary, our planet experienced a prolonged mass extinction known as the Permian Triassic, or PT extinction event. Over hundreds of thousands, possibly millions of years, the PT extinction event eradicated roughly 95% of marine species, 70% of terrestrial vertebrates, and entire orders of insects, making it the largest extinction event of all time. The exact cause of the PT extinction event remains unknown, though it was almost certainly influenced by major volcanic eruptions around the Siberian Traps. Years of intense volcanic activity likely flooded the atmosphere with carbon dioxide, raising surface and ocean temperatures to inhospitable extremes. Acid rain may have poured down on the surface as wildfires raged through dry forests and subtropical deserts. The Siberian Traps probably launched enough debris into the atmosphere to block out the sun and immerse the world in darkness, thus starving many species that relied on sunlight to survive. In this dark, scorching world, many shallow water ecosystems collapsed due to catastrophic losses of aquatic plants, corals, and echinoderms. Certain marine animals, like eurypterids and trilobites, disappeared completely. Even those groups that survived, like bony fishes and brachiopods, were pushed to the brink. The PT extinction event also threatened terrestrial ecosystems, significantly reducing the biodiversity of terrestrial flora and fauna. Resilient plants like ferns and conifers managed to survive the PT extinction event, but many terrestrial animals did not. Sail-backed synapsids, saber-toothed Gorgonopsians, and some heavy herbivores like mozchops vanished from the fossil record. Only a few resilient synapsids crossed the end Permian boundary by adapting to the harsh conditions of the very early Triassic. Pangaea at that time was impoverished and volatile, though not entirely different from the late Permian. After the PT extinction event, the climate was likely warmer and drier, with hot summers and cold winters. Vast rainless deserts and open prairies stretched across the dry equatorial regions of Pangaea. At northern latitudes, sprawling forests were populated by shrubs, woody vines, and tall conifer trees. In these familiar biomes, therapsids were by far the most common terrestrial vertebrates. Herbivorous dicynodonts like Lystrosaurus grazed on shrubs and underbrush, while smaller cynodonts burrowed into the ground, protecting their young from the planet's more volatile climate. Beyond the early Triassic, therapsid populations began to decline, and reptiles gradually dominated the land, air, and sea. Marine predators like nothosaurs and armored placodonts ruled oceanic ecosystems. Meanwhile, terrestrial reptiles became increasingly numerous and diverse. Soon, all kinds of strange and fascinating creatures walked the earth. Some had necks as long as their entire bodies. Others had humongous heads and bone-crushing jaws. These odd creatures ushered in a new age of reptilian dominance, beginning with the emergence of the first true dinosaurs. Exactly which dinosaur species came first remains a subject of controversy. Several candidates, like Eoraptor and Herrerasaurus, emerged during the late Triassic between 233 and 230 million years ago. Not long after, bipedal theropods darted across open prairies, hunting smaller vertebrates with their razor-sharp teeth. Prosauropods stood on their hind legs and grazed from the high branches of towering conifers. These and other dinosaurs diverged into more than 700 known species and likely thousands more yet to be discovered. In many ways, the dinosaurs represent one chapter in a much longer story that began millions of years earlier. Before the dawn of the dinosaurs, our planet experienced significant geological changes, climate disasters, and devastating extinctions. Still, the late Paleozoic brought about a great diversification of life, paving the way for dinosaurs as well as the millions of species we know today.